Good morning, students. Topic for today is Introduction to Data Structure and the Classification of Various Data Structures. Data structure is representation of logical relationship existing between individual elements of data. In other words, a data structure is way of organizing all data items that consider not only the elements stored but also their relationship to each other. Data structure affects the design of both structural and functional aspects of program. Program is basically algorithm plus data structure. Algorithm is a step-by-step procedure to solve a particular problem. That means algorithm is set of instructions written to carry out certain tasks, and the data structure is the way of organizing the data with their logical relationships retained. To develop a program of an algorithm, we should select an appropriate data structure for that algorithm. Therefore, algorithm and its associated data structure forms a program. Data structures are normally classified into two categories: linear and nonlinear data structures. Linear data structure consists of arrays, linked lists, stacks, and queues, whereas nonlinear data structures consist of graphs and trees. Linear data structure is a data structure when all the elements are arranged in linear order. In linear data structure, the elements are stored in non-hierarchical way where each element has the successor and predecessor except the first and the last element. Whereas non-linear data structure is data structure in which elements does not form a sequence, that is each element or item is connected with two or more other elements in non-linear arrangement. The data items are not arranged in sequential structure. Then coming on to linear data structure. First linear data structure is array. An array is defined as a set of finite number of homogeneous elements or same data items. It means an array can contain one type of data only, either all integer, all floating numbers, or all characters. Simple declaration of array is as follows: data type followed by array name and size of array, where data type specifies the data type or type of element array stores. Array name is the name of array, and number specified inside the square bracket is number of element an array can store. This is also called size or length of array. The next data structure is linked list. A list or linear linked list can be defined as a collection of variable number of data items. Lists are the most commonly used non-primitive data structures. An element of list must contain at least two fields, one for storing data or information and other for storing address of the next element. As you know, for storing address, we have a special data structure or list. The address must be of pointer type. Technically, each such element is referred to as node. Therefore, a list can be defined as a collection of nodes as shown below. Each node is divided into two fields: information field and the pointer field. Information field stores the data, whereas pointer field points to the next node in the linked list. That is, the pointer field stores the address of the next node. There is a special pointer called head or start, which contains the address of the first node in the linked list. Linked list has various applications. The first is the circular linked list is used in our personal computers where multiple applications are running. Linked lists can be used to implement stacks, queues, graphs, and trees. They are used to maintain a directory of names, to perform arithmetic operations on long integers, to manipulate polynomials, and to represent sparse. Next comes the stack. A stack is also an ordered collection of elements like arrays, but it has a special feature that deletion or insertion of elements can be done only from one end, called as the top of the stack. Due to this property, it is also called as last in, first out type of data structure, that is LIFO. It could be thought of just like a stack of plates placed on a table in a party. A guest always take off a fresh plate from the top and new plates are placed on the stack at the top. It is non-primitive data structure. When an element is inserted into a stack or removed from the stack, its base remains fixed, whereas the top of the stack changes. Insertion of element in the stack is called as push, and deletion of element from the stack is called as pop. The below figure shows how the stack performs the various operations. Applications of stack include memory management in operating system as well as in portable devices, expression evaluation. Many virtual machines like JVM are stack oriented. In modern PCs, stacks are used at the architecture level, which are used in the basic design of an operating system for interrupt handling and operating system function call. Next data structure is queue. Queue are the first in first out type of data structure. In a queue, new elements are added to the queue from one end called rear, and the elements are always removed from the other end called the front end. The people standing in railway reservation rows are an example of queue. Applications of queue include waiting list and application, task scheduling in operating system, transport and operation research, where various entities are stored and held to be processed later, that is, queue perform the function of a buffer. Coming on to nonlinear data structures. Nonlinear data structure consists of trees. A tree can be defined as finite set of data items called nodes. Tree is a nonlinear type of data structure in which data items are arranged or stored in sorted sequence. Tree represent the hierarchical relationship between the various elements. In trees, there is a special data item at the top of hierarchy called as a root of the tree. The remaining data items are partitioned into a number of mutually exclusive subsets, each of which itself is a tree which is called as the subtree. The tree always grows in length towards the bottom in data structure, unlike natural trees which grows in the upward direction. The tree structure organizes the data in branches which relates the information. In the figure shown, A is called as the root of the tree and the remaining nodes form the subtrees of this root A. Applications of tree include database application and file system in Unix and Linux. Then comes graph. Graph is a mathematical nonlinear data structure capable of representing many kind of physical structure. It has found application in geography, chemistry and engineering sciences. A graph G is a combination of vertices and edges. An edge connects a pair of vertices and many have weights such as length, cost, and another measuring instrument for recording to the graph. Vertices on the graphs are shown as points or circles and edges are drawn as arcs or lines. Example of graphs are the first is directed and weighted graph whereas second is an undirected graph. Graphs find various applications in social networking like Facebook, Instagram, Twitter, and also used in Google Maps and Bing Maps, routing network of communication and data organization. This is all about the various types of data structures. Thank you.